China has accomplished a remarkable feat that may change the way we view the impossible. Their creation of a new nuclear sun replica is a testament to their innovative spirit, challenging the belief that having the sun on Earth is an unachievable fantasy. But how does China's new nuclear sun replica work, and is there any cause for concern? To fully appreciate the significance of China's achievement, we must first understand the extraordinary nature of the sun. The sun is the most massive object in the solar system, accounting for 99.8% of its mass. Its diameter is approximately 109 times that of the Earth, and it could contain approximately 1 million Earths. The sun's surface temperature is approximately 10,000 degrees Fahrenheit, 5,500 degrees Celsius, while its core is much hotter, reaching more than 27 million degrees Fahrenheit, 15 million degrees Celsius. To match the energy produced by the sun, we would need to detonate 100 billion tons of dynamite every second. The sun is just one of the more than 100 billion stars that exist in the Milky Way. It orbits approximately 25,000 light-years from the galactic core and completes one revolution every 250 million years. The sun is part of a relatively young generation of stars known as Population 1, which are rich in heavier elements. It was born about 4.6 billion years ago and has enough fuel to remain active for another 5 billion years. China's new nuclear sun replica works by replicating the sun's nuclear fusion reactions in a controlled environment. This process releases energy in the form of light and heat, just like the sun does. While this achievement is undoubtedly impressive, some may question whether China is biting off more than it can chew. There is a valid concern that things could get out of hand if the technology is not handled responsibly. In conclusion, China's success in replicating the sun is a remarkable achievement that challenges our understanding of what is possible. However, we must also consider the potential consequences and ensure that the technology is used responsibly to avoid any mishaps. The sun is a critical part of our solar system and has sustained life on Earth for billions of years. As such, it is crucial to treat this technology with the utmost care and respect. The sun is an incredibly powerful source of energy, emitting around 63 million watts of energy per square meter on its surface. However, by the time this energy reaches the Earth, it is greatly diminished to only 1,370 watts per square meter due to its journey of 150 million kilometers, or 93 million miles. Despite this, China is building its own artificial sun that is more than 5 times hotter than the actual sun, as they are not content with the amount of energy they receive from the natural sun. Building an artificial sun, however, comes with a hefty price tag of $1 trillion. So why is China investing so much in this technology? The primary goal is to create near-limitless clean energy by mimicking the natural reactions that occur within stars. The artificial sun uses the same process as the actual sun to produce energy, which is the holy grail of clean energy production. This is because the process requires no fossil fuels and leaves behind no hazardous waste materials, unlike the nuclear fission process that powers commercial nuclear energy production. Researchers also claim that there is far less risk of an environmental disaster with this technology. But how does China's artificial sun work? It works just like the actual sun, where the solar energy reaching the Earth is created by nuclear fusion taking place in the sun's core. Nuclear fusion occurs when protons of hydrogen atoms collide violently in the sun's core, fusing together to create a helium atom. In conclusion, China's investment in creating an artificial sun that can replicate the nuclear fusion reactions of the natural sun is an impressive feat that could revolutionize the way we produce energy. By mimicking the natural process that powers the sun, we could potentially create clean, limitless energy without the harmful effects associated with traditional fossil fuel sources. However, the cost of such technology is significant, and it is important to ensure that it is handled responsibly to avoid any potential environmental disasters. China's artificial sun, known as the Experimental Advanced Superconducting Tokamak East, was able to maintain a temperature of 158 million degrees Fahrenheit for 1,056 seconds. This temperature is 5 times hotter than the sun's core and is possible due to extreme pressure and temperature, equivalent to 250 billion atmospheres and 15.7 million Kelvin, respectively. The East uses the tokamak design, which uses magnetic fields to confine plasma in a donut shape, allowing the plasma to achieve the conditions necessary for fusion. This achievement is a significant step closer to creating a source of near unlimited clean energy, as well as a potential solution to environmental disasters. The scientific community lauded this achievement, as replicating the conditions inside the Sun and other powerful stars is no small task. Fusion energy is a promising alternative to traditional energy sources such as fossil fuels and nuclear fission. Unlike nuclear fission, which produces hazardous waste materials and poses the risk of environmental disasters, fusion energy production is clean and produces no waste. The process involves fusing hydrogen atoms together to create helium, releasing vast amounts of energy in the process. The energy produced by fusion reactions is so great that it could provide nearly limitless amounts of clean energy. To achieve this, scientists have been working on creating artificial suns, such as the one being developed by China. These artificial suns are designed to replicate the conditions inside the Sun, where fusion takes place naturally. However, replicating the conditions inside the Sun is no small task, as it requires extreme pressure and temperatures in excess of 150 million degrees Celsius. The main device used for this process is called a tokamak, which is a donut-shaped vacuum chamber in which gaseous hydrogen fuel is placed under extreme heat and pressure, turning into plasma. The plasma is a hot, electrically charged gas that can be controlled using massive magnetic coils placed around the chamber. This control is necessary to keep the plasma away from the chamber's walls because contact between the electrically charged plasma and the reactor walls could cause a near-instantaneous meltdown. One of the main challenges for scientists working on fusion energy has been how to handle a plasma that's hot enough to fuse. Fusion reactors need very high temperatures, which are often hotter than the Sun because they practically have to work at much lower pressures than where fusion takes place inside the Sun. It's one thing to cook plasma to temperatures hotter than the Sun, but it's another thing to corral it so that it doesn't burn through the reactive walls with lasers or magnetic fields, which would have ruined the fusion process. The Chinese artificial sun, known as the Experimental Advanced Superconducting Tokamak, EAST, has made significant progress in this area. The EAST was able to superheat a loop of plasma to 5 times hotter than the Sun for more than 15 minutes, maintaining a temperature of 158 million degrees Fahrenheit for 1,056 seconds. The scientific community has lauded this achievement because it's a significant step closer to the creation of a source of near unlimited clean energy. While the temperatures involved in fusion energy production may seem dangerous, the reality is that the chamber in a modern-day tokamak typically contains less than 1/10 of a gram of hydrogen fuel at any given moment. Additionally, fusion is inherently safe, but scientists are going the extra mile by building a range of additional safety measures into fusion power plant designs. Even if a cataclysmic breach were to occur in a tokamak, it would only create very low levels of radioactivity outside of the plant enclosure. In conclusion, the development of artificial suns is a promising area of research that could lead to the creation of near-limitless clean energy. While the technology is still in its infancy, the progress being made by scientists such as those working on the EAST project in China is encouraging. With continued research and development, fusion energy may one day replace traditional energy sources, leading to a cleaner and more sustainable future. China has invested a massive $700 billion in their EAST project, and they are on track to spend almost half that amount by the time the experiment concludes in June. This project is a precursor to an even bigger fusion project known as ETA, which is an international experimental reactor being built in Marseille, France. The program involves 35 countries, including EU countries, the UK, China, India, and the US. Thanks to the lessons learned during the development of the EAST project, ETA will contain the world's most powerful magnet, capable of producing a magnetic field 280,000 times stronger than the one around the Earth. Designers of ETA claim that putting 50 megawatts of energy into the system to start the reactor will produce 500 megawatts. The internal volume of the ETA tokamak is record-setting, with a plasma volume of 830 cubic meters. In comparison, the maximum plasma volume in a tokamak operating today is 100 cubic meters. ETA's huge plasma volume will enable it to produce, for the first time, a burning plasma in which the majority of the heating needed to sustain the fusion reaction is produced by the alpha particles generated during the fusion process itself. The production and control of such a self-heated plasma has been the goal of magnetic fusion research for more than 50 years. The fusion reactor will come online in 2025, giving scientists even more insights into the practicalities of harnessing star power on Earth. In theory, deuterium, which contains heavy hydrogen atoms, can be obtained from Earth's oceans. 1 liter of seawater is estimated to have enough fusion material to produce energy equivalent to 300 liters of gasoline, meaning we could get an unlimited supply of energy from China's artificial sun. China is not stopping at East, as they are running other programs that develop nuclear fusion power and will finish developing another tokamak early in the 2030s. What do you think of China's artificial sun? Let us know in the comments section below.